Hello, everyone, and thank you for joining us this evening for week 5 of the Rugby Research Injury Prevention Group 2025 Journal Club. My name is William McIntyre. I'm a rising senior at Howard University studying sports medicine. We will begin with our first Journal Club presentation. Our first intern is Asha from Columbia University. Asha will be presenting on effectiveness of the Activate Injury Prevention. Asha, may you please share your screen?
Thank you for the introduction, William. Okay, can everyone see my screen? Perfect. Okay, good evening, everyone. My name is Lasha Gadraj. I'm an incoming freshman to Columbia University, and I will be presenting on the article Effectiveness of the Activate Injury Prevention Exercise Program to Prevent Injury in Schoolboy Rugby Union. So just as some background, rugby union is played by over 500,000 young people weekly, according to a study. Essentially, a lot of schools in the UK and in Europe do play rugby union, and as a result, the Football Union has been promoting the Activate Injury Prevention Exercise Program, essentially to reduce incidents of injuries in young athletes. And Activate essentially is a 15 to 20-minute warm-up program in 7 phases, and it is designed to be completed prior to training and matches. It is progressive as each different bracket between ages 12 to 19 requires different regimen and it's different to age-specific programs. Also, there's been a correlation with a dose-response relationship when it comes to neuromuscular training programs and incidents. So essentially, dose-response relationship is the increase of something causes the also increase or decrease of another factor. So, for example, the increase of a warm-up program such as Activate will be able to decrease incidence. And it has been found in a previous study by this group that 3 sessions per week provides the greatest preventative effect. So in the past, Activate has been assessed in a 2015 randomized controlled trial and essentially found that there were 72% fewer overall match injuries and fewer contact injuries, and also almost a 60% reduction of concussions. However, in terms of pervasiveness, only 16% of teams managed to complete Activate 3 times weekly, or the suggested amount. So essentially, they found that lower adherence rates correlated to a lower reduction of injury in sport overall. The less teams that decide to use Activate will result in a lesser impact when it comes to the reduction of injury. So essentially, the aim of the study was to assess the effectiveness of Activate to lower match and training injury rates in schoolboy rugby union from under 12 to under 19. And then a secondary aim was to examine the dose response relationship between the weekly Activate adherence and injury incidents. The methods for this study, this took place between the seasons of July to September and December and April to cover the different rugby seasons and also schools, depending on schools and competitions. There was an email sent to head coaches of multiple schoolboy rugby teams, and they were provided with an Excel sheet to collect the following data, which is rugby attendance, rugby exposure, injury data, and then Activate use throughout the season. Now, keep in mind, Activate was widely disseminated on the web in 2018, and so in this particular methodology, they didn't inform the head coaches that they had to use Activate. It was more of a trial to see how many coaches would use Activate without them being told to do so. Median weekly Activate adherence was calculated by cross-referencing attendance registers and then the team's Activate use for that season. And this is essentially a type 1 study that basically observed over and over again how Activate would impact the incidence of training and match injuries, and also observed users voluntarily using Activate. So once again, these coaches weren't told to use Activate. These Excel sheets were sent out to essentially see if these coaches were using Activate based on the Rugby Football Union guidelines. And then the injury report that these head coaches were provided detailed player name, injury date, return to full participation as deemed so by the head coach, training and matches, mechanism, body location, and injury type. So essentially recording information on their injury. So as a result, 13 schools, which consisted of 25 teams and 659 players, were included in the study after being narrowed down due to a few exclusion criteria. Out of 25 teams included in the study, it was shown that over two-thirds or 16 teams voluntarily adopted Activate during the season in some shape and form. And the cumulative utilization was 98%, with 13 teams out of the 16 using Activate at all sessions, and one team using Activate at 70% of sessions. However, only one team implemented Activate 3 times per week, using each phase in its entirety. So as I mentioned before, Activate is a 7-phase plan. Some teams did 1 to 3, some did more than that, but they never actually diligently followed all 7 phases the way this one team did. Also, individuals from teams adopting Activate, which were 16, had about 17,000 player hours with 84 injuries, and this is compared to non-adapting teams, which had roughly 8,000 player hours and then 60 injuries. So we could see that the incidence in terms of injuries that the teams adopting Activate had a lower incidence compared to the non-adopting. And this is the results continue. This is a forest plot. And RR just means risk ratio. So essentially this number means, so 0.44 means that there is a 50%, 56% decrease in risk. So essentially when you compare, the numbers you really want to see are comparing low to high. This is comparing teams that had a low adherence to Activate compared to high adherence. And it is shown here that with this number, 0.33, that there was an over 66, well, in this case, 67% lower training injury incidence. And then looking at this number, 0.68, and a 32% lower match injury incident than individuals with low adherence. So essentially, high adherence had much lower incidence than the teams with low adherence. And the same thing goes over here. If you look at the numbers above, individuals in teams adopting Activate had a 23% lower match injury incident and then a 59% lower training injury incidence compared to non-adopting teams. And then match injury burden was 26% lower in the adopting group. So for the discussion, adopting teams did report high cumulative utilization, like adopting Activate at 98% of sessions, and the utilization frequency was about 3.2 Activate sessions per week. Individuals adopting Activate had a median adherence of 3 times per week, and this was much of an improvement from the original efficacy study done in 2015. And this study essentially confirms the dose response relationship that was brought up before between adherence and injury incidence. Once again, a higher adherence correlates to a lower injury incidence. And most teams modified the program content, which is common in sports injury prevention literature. So this is a fascinating topic in which, while the Rugby Football Union publishes their suggestions for how Activate should be structured, head coaches may tailor that to how it could impact their own teams. And so there's a lot of subjectivity when it comes to implementing these plans. So a few limitations for the December to April season. COVID-19 happened right around the middle, which impacted the participation of a few schools. Unfortunately, they could not reach out to certain head coaches due to the pandemic, and so they had to be taken out from the study. Warm-ups employed by non-adopting teams were not investigated. So while with the 16 teams we knew they were using Activate to warm up, it was not known or studied how the other 9 teams were warming up and what factors may have contributed to their incidence rates. There also is a need to assess the Activate effectiveness in other populations as the program has been promoted worldwide, thus opening greater populations to be studied. Also, the extent to which programs can be modified before losing their preventative effect have not been studied yet. As I mentioned previously, coaches tend to update or modify given plans to suit their teams. And it is also unclear whether these results are applicable to a schoolgirl rugby population. So in conclusion, this is the first study to investigate the effectiveness of the Activate Injury Prevention Exercise Program to prevent injuries in schoolboy rugby union. And overall, there was a positive finding with an increased Activate usage with decreased incidence, with 3 times per week having a significantly lower training match incidence compared to teams that did one or less than 1 times a week. However, Activate was not often implemented as intended, and so teams not using whole phases, failing to basically fail to progress in the program. This could impact how their teams warm up and how injury incidents can be studied in the future. This is my reference. And are there any questions?
Hey, Asha, this is
Yes.
Philip Tessick of the University of Michigan. I thought it was a really good presentation. I think you did a good job of explaining the risk ratio and how that applied to study. I think one of the best ways to really explain the risk ratio is comparing the exposed group to the non-exposed group. So you're comparing the injury rates of the people who, the teams that went through the injury prevention program versus not the people who weren't exposed to that program. And with that, if the risk ratio is less than one, then there's a decreased risk in the exposed group, and if it's greater than one, then there's increased risk. So here, because the risk ratio is under the value of one, it's a decreased risk in the exposed group. I think we're going to talk about that probably in one of the analytics series coming up.
Yeah. Good point, Philip. And just so everyone knows, this one here is kind of the null value. So anything one just basically means there's no impact. Are there any other questions?
Thank you for the presentation, Asher. It was very informative. Our second intern is Philip from the University of Michigan. Philip will be presenting on injury trends of school rugby. Philip, may you please share your screen?
Of course. Can everybody let me know if they can see my screen? Okay, sound good. So today I'll be speaking on injury trends for school rugby union, specifically in Ireland. And this is a study that evaluated um, the injury risks and rates within specific cohort, and it also speaks about the need for specific position prevention programs to prevent high injury rates. So just as a bit of a background, of course, there are a lot of varied statistics on this, as Ash mentioned in her presentation, about 500,000 play weekly. This study actually cited that there was over 200 million children worldwide playing rugby union 15s. However, that's not weekly. And that paired up with the very high incidence rates in professional rugby union, as well as the very sporadic rates, ranging all the way from 23 per 1,000 player hours to 130 per 1,000 player hours. It caused a lot of speculation, and it really showed a need for the study to really evaluate a specific cohort within the country of Ireland, and specifically the age group of 16 to 19. So in the study, they evaluated senior school rugby, which represents the most elite level of competition at local schools. And also, this was very important because that injury rate had not been established. And this study sought out to establish that injury incidence rate, but also look at the injuries varied on playing position and the injury locations anatomically by describing the incidence, nature, and severity of these match injuries. So the study was set up as the prospective cohort study, part of the Irish Rugby Injury Surveillance IRIS project, which was a nationwide project sort of joined in to establish if there was a possibility of implementing a surveillance project that would decrease these high incidence rates that were seen in the literature. And this study looked at senior cup teams and that specific division as the most elite at the school level, and specifically 15 teams over 2 seasons from 2018 to 2020. Injury data was recorded at their matches by injury recorders. These injury recorders, as I'll get to a bit later, did vary in level of their qualifications. Some medical personnel, some also employees of that school or that team, including a coach or a school nurse. And this data was analyzed after it was recorded by these recorders and analyzed in correspondence with consensus statements to look at the incidence and the discrepancies for playing position injury locations. Overall, they had very high compliance with over 90% of the teams complying with their injury reporting process and continue on into the second season. They had 339 players the first season and 326 in the second. And throughout these two seasons, they found a total of 207 time loss injuries that were recorded over these two seasons with a total burden of 6,810, which was relatively high, as well as a very high time loss injury rate of 53.6 per 1,000. But most importantly, was found that there was a very high discrepancy in these rates for time loss injuries between forwards and backs, with forwards taking up a large majority and backs taking up the minority of these time loss injuries. For the mechanisms, 64% of these match-related injuries occurred during the tackle, which was not too much of a surprise and is seen in a lot of other articles related to this as well, as mentioned in this research article. But as well, the shoulder, head, and ankle were the most injured locations, specifically um, the lower limbs and the upper limbs took up the vast majority of the injuries, but for specific injured locations in the body. It was the shoulder, the head, and ankle. The ankle, of course, being part of the lower limbs, the head being part of the head and neck area, the shoulder being part of the upper limb. Sprains and strains made up almost half of the injury types, and those were by far the most common. The sprains had an incidence rate of 17.6 per 1,000 player hours, and the strains had 8.3 per 1,000 player hours. The forwards sustained an overall injury rate that was 1.61, the rate of the backs, and this had an extremely low p-value as demonstrated in the study, which was, again, as we spoke about in our analytics series, very high confirmation that this was not due to chance because the p-value was so low that we could extrapolate from this that forwards are experiencing within this cohort a much higher overall injury rate than the backs. They also sustained higher rates of shoulder and head injuries in backs. However, the shoulder injury burden was highest for backs, even though the forwards had the higher injury rates for shoulder and head injuries. The forwards also sustained higher rates of concussions and hematomas than backs, but the concussion burden was highest for the forwards. This is a table that depicts what I just went over right here. So as we can see, the forwards have much higher injury rates for the shoulder and the head compared to the backs. But when looking at burden, the backs actually had a higher burden for the shoulder injuries, which I guess speaks to the severity of these injuries as there weren't as many with the much lower incidence rate, but the higher burden and time loss. Looking at the time of the injury within the studies within the matches that were analyzed, 40% of the injuries occurred during the third quarter. However, there was no significant relationship between position and time of injury. So while there was a much higher rate of injuries within the third quarter, that did not apply specifically to forwards or backs. Looking at how we can really use this data to develop some conclusions, the forward sustained injury rates at a statistically higher rate than backs, and the backs are at a statistically significant higher risk for concussion than the backs. On average, senior school rugby teams can expect to lose 423 days due to injury, and comparing with existing literature, the lower incidence rate from a previous sport report on elite schoolboy rugby and union, there was a higher incidence rate for the 24-hour time loss definition, even though there was a lower overall incidence rate. Looking at our conclusions from this, we can see that the difference in injury rate between the forwards and backs are not consistently reported in the literature, even though we saw such a low p-value in the study, which speaks mostly to the general incidence rates regarding rugby. But in this specific cohort, we can be pretty confident that these results were not due to chance. The shoulder, head, and knee and ankle injuries are the most prevalent across elite, amateur, and school level rugby, as this was um, demonstrated in other journal articles as well, cited in this study. and the timing of injury aligns with most existing literature, but is not widely studied in school rugby settings. So this is one of the first studies to do so. Looking at the strengths and limitations, some of the things that made this study very strong were that they had a very large cohort of the amateur school rugby teams and the high compliance. And because of that, they had a strong external data validity from these researchers, and they standardized it to the consensus statements, which is very useful in analyzing and um, expressing the data out and comparing with other journal articles. However, the limitations were that while it was a prospective cohort study, training was not surveilled or monitored, which is important if they're going to look at the same cohort over time. And the injury recorders varied in qualifications. Not all were medically certified. This is my reference, and are there any questions?
Hey Philip, this is Gabriel from Adelphi University. I thought you did a great presentation. I was just wondering what you meant by if you could go back, I think just 2 slides. You said something about strong. If I don't know if you can share your screen again, it just slipped my mind. That's
Yeah,
fine.
one second.
Thank you. It was in the strengths and the limitations slide.
Can you see my screen?
Yeah.
There.
Um, so you said there was strong external data validity. I just wanted to know what that meant. If you could expand it a bit, please.
So they used a reporting system the day of at these matches where the data recorders would record the injury data regarding their playing position and the time of the match and the anatomical regions of the injury, all the things that they were able to analyze with this. But as they included this into their larger data set over the 2 seasons, they had this verified with their data scientists as a part of the organization. And I felt like that added a strong validity to their data, that they were able to process it very well. They were able to analyze it on a larger scale.
Thank you.
Yeah, very good job there, Philip. Can you hear me all? Thank you so much sorry for the delay. With regard to this study, I think they Tom Commons and that they try to do a good job in regards to analyzing the data for youth rugby in Ireland. But possibly due to the short window of data that they collected, they weren't able to make any correlations between position and time of injury. I think when you're playing a 15s match, not like what we normally evaluate in regards to the sevens, the 15s match is a very long game. So I would probably say that there are correlations between position, and this has been seen in senior rugby and club rugby, but not analyzed, I guess, in schoolboy rugby. But the importance is there. It is seen, but maybe due to the fact that they had a small cohort, only 2 years, right? 2 seasons.
Yes.
And even with the IOC consensus statement, they say they want you to collect data from more than one season. So they satisfied that. But again, when you really want to see this data give you outcomes that show significance for the cohort and injury surveillance per se for injury prevention, you need to do longer term studies and long windowed, regression analyses, longitudinal analyses for a long period of time to really get that kind of data. But anyway, thank you, Philip.
Thank you, Dr. Lopez, for your comments. We will now move on to our third and final presentation. It'll be done by Gabriel from Adelphi University. He is a junior studying nursing. Gabriel will be presenting on acute effects of breath hold in aerobic fitness life. Gabriel, may you please share your screen?
All right, give me 1 second. Sorry about that. Just want to make sure, can everybody see the screen? All right, we're good. All right, so good afternoon, everybody. Thank you, William, for introducing me. As you said before, my name is Gabriel Moreno. Today I'll be presenting on article that's called "The Acute Effects of Breath Hold Conditions on Aerobic Fitness in Elite Rugby Players." This was presented in the Journal of Life in 2024 by Wang et al. So to begin, I want to give some key terms and some concepts. The reason why is because this will help you understand the data later on, because some of it I was unfamiliar with. And I think it might help out to give some background on what was done in the study. So let's begin with face immersion. In this context, face immersion, it means exactly what it sounds like. It's putting your face into water, like dunking your face into a bowl of water. And in this case, it was between 10 to 11 degrees Celsius while holding your breath. In the study, wet conditions referred to holding your breath while your face was immersed in water, and dry conditions, it meant just holding your breath, like as you are, dry. The researchers studied this because immersing your face in cold water could help trigger the diving reflex, which is a reflex that's common in all mammals. So, what's the diving reflex? This is a natural reaction your body has when your face goes into cold water or your entire body goes into cold water. This reflex, it helps you to save oxygen so that you can survive longer underwater by sending the oxygen-rich blood more towards your brain and your heart. So when this happens, your body does three things. It slows your heart rate down, so that's called bradycardia, and it redirects blood flow away from less important areas, let's say like your arms and legs, towards your vital organs. This also increases blood pressure and it reduces oxygen use to non-essential tissues like your peripheral tissues. So a question you might have is, so if we're sending blood flow away from our arms and legs, wouldn't that be counterintuitive to what we're wanting to do if we're going to be running fast and training? In this case, for athletes, the benefits comes after you finish the breath hold or the face immersion. It's not that you're going to get the benefits while you're doing it. The reason why is because when you do the breath hold exercises, especially when you trigger the diving reflex, your spleen is going to contract and this releases extra red blood cells into your bloodstream. So when you have more red blood cells, it means your body can carry more oxygen, and that's going to be a benefit once you start working out again. You could think of this as priming your body for intense exercises or intense activities. So this shift in blood flow and this activation of the nervous system, it's going to help prime your body for that exercises. And after the reflex, your body bounces back and it sends blood with all that extra oxygen right back to your arms and legs, which could potentially improve your ability to perform high intensity exercises. Repeated exposure to this breath hold, this could train your body to be more efficient with oxygen and improve your tolerance to higher carbon dioxide levels in your blood. And this could also help get your cardiovascular system ready to respond quickly once you're going to start moving again. With that being said, I want to give a quick rundown as well as to what each one of these variables does in the body so that we understand the results a bit better. So with red blood cells, we're all pretty familiar with this. These are the cells in your body that carry oxygen from your lungs to your muscles and other tissues. In this case, why would more help? So the more red blood cells you have, the more oxygen your blood can carry and deliver to the working muscles during exercise. So the performance benefit would be more oxygen to muscles and higher endurance and better performance. Now, red blood cell volume. This is one of the variables that was measured in this experiment, which is why I want to explain what it is. So what is it? It's often called red cell mass, and it refers to the total volume of red blood cells in your body. Similar to before, a higher volume means you could carry more oxygen, and more oxygen is going to help you support endurance and recovery during and after these tough exercises. Now, hematocrit. What is this? This is the percentage of your blood that is made up of red blood cells. And why would higher levels help out in this situation? So a higher hematocrit means that there's a greater proportion of your blood that can carry oxygen. Again, so higher hematocrit is associated with better endurance and aerobic performance. It's sort of why sometimes you'll see athletes doing altitude training or training with the mask that restricts oxygen. The VO2 peak, again, is another variable. What is this? This is the highest rate at which your body could use oxygen during intense exercise. Why would a higher VO2 be, why does it matter? So higher VO2 means that your body could use more oxygen, which is critical when you're working out really fast. You need to get oxygen to your muscles. So athletes with higher VO2, they could work harder for longer times, as well as recovering faster between bursts of activities. So like in rugby, let's say you're sprinting, you'll be able to recover faster and get right back at it. So peak stroke volume, this is related to your heart. It's the maximum amount of blood your heart pumps out with each beat during exercise. In this case, it makes sense why a higher value would help, because if your heart can pump more blood per beat, that means it can deliver more oxygen to your muscles with every contraction. The COP, or cardiopulmonary optimal point, is another variable that this experiment went over. And I think it's important to understand it before I start giving you the numbers. COP is the point during exercise when your breathing is most efficient compared to how much exercise you're using. So the reason it matters is because in this article, a lower COP means that your body can deliver and use oxygen more efficiently during exercise. So you could think of COP as a sweet spot where your heart and lungs work together. It's where you get almost like the most out of each breath with the least effort. And let's talk about this study. What is this study bringing that's new? What's the purpose? Why does this study matter? So previous studies looked at either exercise or phase immersion and breath holds. They didn't look at both together. In this study, they looked at both. What happens if I'm working out and I try these breath hold warm-ups? Another thing is that nobody really tested if combining movement with different breath holds, if that's going to impact athletic performance. And the last thing they wanted to see is if these breath holds or BH, if this could be even practical and be used as a warm-up tool. So how was the study done? The participants, it was 18 elite male rugby players with very similar age, fitness, and experience. For the preparation before the actual tests were done, each athlete was told to not have caffeine or alcohol 48 hours previous to being tested. They must have at least 8 hours of sleep, and they all wore the same shoes and clothes, obviously depending on size and fit, but that was the same shoes and clothes. And there was 5 warm-up conditions. So this breath hold technique, it was done as a warm-up to help enhance the actual workout. Everybody did all 5 warm-up conditions, and it was once per week. So this was a study that lasted at least 5 weeks per player. The first warm-up was the regular, or the control. This was normal breathing and cycling without any breath holds. Then it was a dynamic and dry. So this means that they were cycling while they were holding your breath. So you're moving and holding your breath. Then there was static dry. This means that they were sitting still and holding their breath. Now, wet dynamic and wet static is the same thing. It's just that in these cases, they had their face immersed in water to help trigger that diving reflex. So why would they even want to explore the difference between dynamic and static? And the top, that's exactly what it says from the article. And to simplify that a little bit, a dynamic breath hold, so with movement, it's gonna stimulate what's gonna happen in sports better. When you're working out, it's gonna help increase your heart rate and oxygen consumption, and it'll also help send more blood to the muscles you use when you're playing. However, in static breath holds, it's gonna mimic what happens during diving, where your body is still. So it's gonna prioritize blood flow to the essential organs like your brain and heart instead of the peripheral muscles. So how was data collected? What was the tools used? How was this done? For the cardiopulmonary test, they used a stationary bike, and this bike, it had different things. It could measure the oxygen use, it measured the heart rate, and it measured the anaerobic threshold per athlete. For the hemodynamic data, they used a special non-invasive monitors. So they didn't use any catheters or got any blood out. This is called the Cheetah NICOM, and this was used to measure the stroke volume and the cardiac output. And for hematology, they just did a finger stick blood test before and after the warm-up for the hematocrit, the red blood cells, and hemoglobin. And each athlete had a random order of their tests. That way, it wasn't an influence of, hey, maybe the order matters. Every athlete had a random order. And this was the way it was done. It began with a 3-minute stretch, a 10-minute warm-up. And during that warm-up, that's where you do the breath holds. So it'd be 6 times your max breath hold with a 30-second rest in between each set of breath holds. Then there was a blood sample test done before and after. And then there was a bike test. During each breath hold, the athlete held their breath for as long as they could. Then they rested 30 seconds. And they did it 6 times before continuing to the actual workout. Now, these are the results. The results are split up into different sections. So these are the results specifically for the cardiopulmonary parameters. So for VO2 peak and VO2 per kilogram peak, it was higher in all breath hold groups compared to regular breathing. So doing a breath hold, no matter what, it helped to increase this. So the dynamic breath hold, so moving with a breath hold, was better than being still and holding your breath. And being dry was also better than having your face immersed in water. For COP, or cardiopulmonary optimal point, The highest measurement was after the dynamic wet breath hold warm up, but it didn't make much of a difference. And for anaerobic threshold, there wasn't a big difference between the groups. So the breath hold warm ups, especially when done dynamically and about face immersion, these were the ones that led to higher peak oxygen uptake, which is good for performance. Now for the hemodynamic parameters, CO2 peak and heart rate peak, there was no major differences between any of the warm-up types. This just means that heart rate and total cardiac output at max efforts were similar for everybody. Now for stroke volume, the dynamic dry, so moving and no water or anything, the breath hold group, that had a significantly higher stroke volume than all the other groups. So this group was pumping more blood per heartbeat. And the interactions that went on with these was that doing dynamic movement, so moving with your face in water, it made the heart rate peak a little higher compared to the static, but it wasn't by a big margin. And for both face immersion and movement during warm up, they all had effects on stroke volume and cardiac output. Now, this is some of the more important results. This was the VO2 peak correlation and regression analysis. So here they wanted to see if changes in blood markers, if these were linked to any changes in aerobic performance after the different warm-ups, especially after the dry breath hold. So the correlations were that in the dynamic dry, so moving and no water, the athletes who showed the biggest increase in red blood cells and hematocrit, these were also the athletes that had the biggest improvements in their VO2 peak. And the correlation was very strong. It was 0.84 for red blood cells and 0.77 for hematocrit. However, the hemoglobin levels, it didn't show any connection or a significant connection with VO2 peak changes. So what does this mean? The more your blood was able to carry oxygen because of more red blood cells or higher hematocrit, right after this warm-up, the better your aerobic performance was. So a few limitations of this study is that it was only tested in elite young men. So it would be nice if we could get information for women, for kids, for older adults, or those without any issues or health problems. Another thing is that the effects that were measured were just acute or short-term. They didn't go over long-term effects, if this could possibly be negative if you continue doing these breath holds. And another limitation is that you can't really try this if you have heart or breathing issues or if you get easily dizzy, because it might not be safe. Something that it might be similar to is that the breath hold warm-ups that were done in the study are different than what's called the Valsalva maneuver, which is when people take a deep breath and hold it while lifting heavy weights. Those are a couple of different things I just wanted to clarify. And this is just a quick summary of how to really apply this into real life if you want to try it for yourself. So you'd begin with a short, easy warm-up, maybe 10 minutes of jogging, a bike, or anything. After your warm-up, you're gonna sit and stand comfortably. You don't need any special equipment or any water. And you're gonna perform 6 maximal breath holds. So you're gonna take a normal breath and don't fill your lungs to the max. Then you're gonna exhale normally, and you're gonna just hold your breath. Once you feel the strong urge to breathe or any discomfort, you're gonna let go and breathe normally again. You're gonna rest 30 seconds. And in between those 30 seconds, you're gonna breathe normally. You'll repeat this for a total of 6 times, and don't push through if you feel lightheaded or if anything falls off. Then, once you finish that, you're gonna resume to your actual activity, and this should help make you perform better, resist longer, let's say if you're doing sprints, help recover better during sprints, or even last longer if you're going on a long run to help you last or be able to perform better during those long activities or those short bursts of intense activities. These are the references, and if anybody has any questions, please feel free to ask.
Thank you, Gabriel, for that presentation. This will now conclude our call for today. We thank everyone who joined us for our Rugby Research Injury Prevention Group lecture series. Thank you.
Sorry, I just got a quick question, please. Thank you. So Gabe, yeah, that's a great study. Thank you for bringing that up. The question I ask is, you're saying that the outcomes or the application could be that you can do better with the longer runs, but they didn't find that out in the study. Am I correct that the outcomes of the study didn't give you the results of that, right?
Yeah, it was something similar to that, but what they said is like they try to make it make sense so that with the athletes that they showed, it showed that compared to regular, the static breath hold or dynamic breath hold, it just had a small increase. It might not be something too extreme, but it did show that it might help perform a little bit better because of the increased measures of blood. But it didn't specifically say that it will result to better performance. It just said that it may because of what was measured in the blood test that they did on the finger.
Well, yeah, first of all, anyone understands doing any study with blood is very, very challenging, very, very hard to keep the quality of the blood, the temperature, transporting it, making sure the athletes get their blood drawn at the appropriate time. All of this, affects, and this is why in the hospitals, the labs are drawn immediately and sent right to the lab. They can't be unattended. And so, did they discuss how the blood was protected, or maybe you didn't go into it, but maybe they did?
They didn't go into what they said is they did the blood prick test and that was it. And they didn't really go to explain in the methods, they didn't go really deep into how the blood was handled or taken later on.
Because that's probably the number one thing I see that, obviously the findings are great. And not only that, but the idea, and we can definitely have seen this for any of us who've been, athletes, or even you could just imagine just doing this. How long did they do the breath holds? 6 breath holds within.
So you would hold your breath for as long as you can, and you do this for 6 reps. Between each rep, you just do a 30-second break. And then that's what they did.
4 or 5 minutes, right? Just think about if
Yeah.
you had added 4 minutes to your workout to improve your overall performance. These are the kind of things that, and reason why, I'm glad you brought this study up. I think it's impactful, but it's also important to understand these are little changes that can be applied, but not only in any sport, but in any athlete. So para athletes or ambulatory athletes. I mean, these are things that can be done and improve their performance without too much effort, or even if a para athlete has issues or limitations. You agree, everyone, right? This is something that can be applied easily and have outcomes. This is really kind of important stuff to be presenting. And not only that, but being aware of that, as we are all aiming to be somewhere in that kind of an analytic capability to improve performance in some capability. So it's a good study. More importantly, thank you, Gabe, for bringing it up. But like I said, I just, it's questionable, like how they did prick test. And then, like I said, so they gather all this data from it. Obviously, they did a lot of other lab work evaluating the athlete overall. So it's very important to understand this is a very detailed study. So to do these kinds of studies with blood and, evaluating cardiac heart rates, stroke volume, that's the kind of stuff that you can really, hang your hat on if you're looking at this kind of work, if they've done it correctly. And that's really what if as long as the blood was protected, they should have commented at least minimally about how the blood was, the integrity, right? Because we're basing all our findings in the study on that blood. Yes, everyone? That's all I'm saying.
Well, Dr. Lopez, what they did say, now I'm looking back on it, is they followed the Chinese consensus on the operation of capillary blood collection. And so that's just like in their consensus, they make sure that the blood process is safe and hygienic for the participants, that they're high quality, not contaminated. And in regards to the immediate processing, it also says that the finger stick blood samples, they were immediately transferred to the laboratory to measure the different blood parameters. That was what it said, like verbatim.
Yeah. So where are these athletes going to be? On the field, right?
Yeah.
They got to get them to the hospital, get that. The labs are most likely in the hospital or at a laboratory. So like I said, that transport, is, like I said, you know why? Because in the middle of the night, when you got to get blood to a certain floor to, get results, I'm telling you when it matters. So you need to know how that blood is protected and how it was transported. Again, no, I think the study was phenomenal. Not only that, I think the concept and its application, but like you said, it needs to be looked at in more detail. That's all. Thank you. So I'll put this question out there. Did anyone have any other questions before I begin? I wanted to ask one more question about this study. So does anyone have any questions for Gabe about this? So just discussing here in the group, do you think employing this hold breath scenario would have been applicable in your training scenario? So, in whatever sport you may have played, hypothetically, just whatever, you think you could have done this or applied it? And that's what I guess I ask. Let's Gabe, start with you, maybe military training. Do you think you would have been given time to maybe do this? Or do you think that it doesn't seem like it would be practical?
The thing is, it's tough because in the military, when we were all getting trained, we couldn't have somebody looking at each person. So if somebody got dizzy trying this, then it'd be trouble because we're gonna go on a long run carrying about 50, 60 pounds for what, 12 miles. So that's gonna mess up their performance right from the jump. And we don't know if they would have been all right if they didn't even try it in the first place. But for the potential benefit, which it seemed good, but every person is different, especially in a condition like that where we aren't getting that much food. We're not sleeping as well. These athletes, they had no caffeine, no alcohol, slept 8 hours before.
I know it was
Yeah,
the
perfect
ideal
conditions.
scenario.
Yeah.
I'm exactly. That's what I was gonna hone down, and I think Gabriel, you know exactly where I'm going with it. So, Willie, when you were with football, do you think that you could have employed this?
I think I could have, yes. I feel like if I like increased my VO2 max, I feel like because football is like a really like intensive sport and like it's not really a lot of breaks in football, honestly. So like if I just would have like, like the actual good blood flow, I feel like that actually helped me a lot. So yeah, I do think so.
I'm not saying if you think it, you needed it. I'm asking you in the training program that you were in, do you think it would have been applicable? Do you think they would have let you do it, or do you think the
I don't I don't think so just because of our age because I played football when I was like 10 or 11. So like doing that young, I don't know how the effects might be later in life. So I'm honestly not sure, but I don't think so, no.
So sorry to interrupt, but Dr. Ma is in the waiting room.
Oh, bring them on. Bring them on. Don't worry.
Yes.
We're just chat. We're just chatting. So, Larry, let me ask you this: do you think that in lacrosse, do you think that would have been applicable doing the breath hold?
I don't see why not. I mean, whoever wanted to do it could do it. I think there was always time made for it. Like you could always do it before a game or practice. And at the level I played, you were old enough to, do it on your own and without really being worried about risks. It was mostly adults. So yeah, I don't see why not.
Okay, no, I did my conditioning as well separately, so I was just asking. Thanks a lot for joining us, Dr. Ma. How are you this evening? We were just going over the breath hold.
I'm doing okay, man. I found the Zoom link. I apologize. I had to, I think I emailed Asha and Phil, but I
That's all
found
right.
the emails, man. So
I was also a little late today as well. But why don't someone send Dr. Ma this article so he can process it at a later time? So this is a study where they employed maybe the breath hold or the diving reflex idea where you can improve VO2 max, stroke volume, obviously shunt blood to the core, um, enabling athletes to maybe have a better overall performance during training and maybe during the season in general by employing this. So I guess I was going through the different sports that some of some of our former athletes played. Lily, do you think that would have benefited you in soccer?
Like Larry said, I feel like it could have, but especially during our training, like summer season, getting up early, like we're not getting adequate sleep. I mean, in high school, not everyone's following the same routine. So I feel like it could have been beneficial depending on your situation. I probably would have liked to try it. But yeah, I think it would be hard to get everyone on the same page.
I'll ask you a tougher question. Do you think your coach, dad, would have allowed that?
If it made us better, yeah.
All right.
Yeah, anything to make us better, he would have been on board with.
Interesting, interesting. How about you, Philip, on endurance runs? What do you think about that?
Yeah, I've heard a lot of different breath hold techniques. I think that there's been what I've always heard about is doing certain like mechanisms to make sure you breathe through your nose. So certain runners they've like ran with water in their mouths just to force them to run to run while breathing through their nose. I wonder if like mouth tape now that that's becoming used more, maybe some people are going to try to use
I
that.
heard about that. Rich, have you
Yeah.
heard about this yet?
No, I mean,
Oh,
I
Philip,
don't,
why
I
don't
don't
you
think,
explain this to me? I thought this was pretty out
yeah.
there. That's about,
Yeah. Mouth tape, it's sort of like a new trend in it kind of bounces between like a couple different sectors, but so in medicine, it's said to help with your breathing mechanism through forcing you to breathe through your nose by taping your mouth closed while you sleep. So people with like sleep apnea can help them with that, or if they have snoring issues, that's what a lot of people argue. Some people they also can claim that it can make you more attractive by rerouting like the way that you breathe, making your jawline more um uh sort of like sharper because you're not no longer breathing through your mouth. And it forces you to keep your mouth closed. So it's sort of like a big thing for people to try and sell and buy right now. But yeah, as I was mentioning, I wonder if that would be like something people could use while they're working out, or at least try to, if they want to force themselves to only breathe through their noses while they're working out.
I'm sorry, really, I'm out on, I can't comment on that one. I've heard of it. I've never seen it applied. I just don't think it would be practical, um, to put the mouth tape on, or I think, I get the idea, even with hiking, you want to try to breathe through your nose versus your mouth. You lose a lot of temperature, core heat when you're hiking in the cold, and, you want to warm the air in through your nose. I'm well aware, done a couple different things to try to emphasize that as well, but I don't think I've done would um, go to the mouth tape or the water in the mouth to keep my mouth closed, though. That may be challenging. But anyway, on that note, we were talking about breath hold and its importance of to possibly impact. So when you send that paper over to Dr. Ma, he'll process it as well for his athletes.
Yeah. I'm gonna have to. Well, it's interesting because like I work with the track and field team, including the cross country team, and I can't say I've seen this. But then I'm not out there doing the practice. I only see them doing competitions. So
Mm.
I do think anything that has a competitive advantage, somebody's gonna end up doing, kind of like what Leonatos was saying. Um, I don't know. I just quickly pulled up what one of these things look like. I mean, some of these are scary. Like, I mean, like if I turn around, turn over, my wife had one of those on, that'd be interesting. So yeah. So
Well, so Willie, thank you for concluding. And did you want to say anything else? Thank you, Gabriel, for presenting that. I just want to make sure we had a discussion about it. The topic, I think, is applicable. I said, so Dr. Ma said it's very applicable to employ this breath hold study in multiple athletes as well as para athletes. So I want to paraphrase, summarize of why I think it's important. It's an easy thing to employ if you're going to get a boost in performance. All right, Willie.
Thank you, Dr. Lopez. That will conclude week 5 of the Rugby Research and Injury Prevention Group Journal Club. Thank you all for attending.